Hi, welcome to our pre-calculus. Today's topic is power reducing identities. Let's go quickly take a look at the type of problems we are going to look at, and we come back and start the lecture. So here's the first problem. Sine to power of 4 of 4x is an expression that is given. We want to write it in terms of power of the first power of cosine. So sine to power of 4 of 4x. How can we fit it in this form? Right hand side is just the first power of cosine. Similar problems. This is sine squared, cosine squared. This one is cosine to power of 4. This one is tangent squared, cosine to power of 4. So some combinations of powers of trig functions are given, and we want to reformat our answer and write it in some other way. First, let me just put the problem in general terms and talk a little bit about what's the significance of this and what are the tools we have for handling it. So you remember from the last lecture that we have double angle identities. So double angle identities, we had in particular cosine of 2a was there are three formulas for this thing. We are going to make use of two of them. 2 cosine square of a minus 1, and another form of it, so another form of cosine of 2a, 1 minus 2 sine square of a. There were lots of others as well, but we are not going to use them directly, so I don't make a mention of that. Well, we can rearrange this formula. I can take this 1 to this side, so it becomes 1 plus cosine of 2a is equal to 2 cosine square of a, and that one tells me cosine square of an angle is 1 plus cosine of twice that angle divided by 2. Same arrangement applies here. So I'm going to take cosine of 2a to right, 2 sine squared to the left. So I'll have 1 minus cosine of 2a is equal to 2 sine square of a. So do a rearrangement, you get that. And out of that you get sine square of a is equal to 1 minus cosine of 2a over 2. Okay, so the most significant formula in this section are just these two. These are what you're going to be using in your physics and engineering classes, because in alternating current, the voltage is proportional to cosine, power is proportional to square of voltage, so you get this kind of an expression. And to do various kind of things in more advanced courses, things such as integration, you would need to modify it to double angle and then perform your integration. So the main application is that. Mathematically, however, we extend this idea to, well, how about other powers? 3, 4, 5, 6, and so on. What happens? What happens is that that power kind of goes in front of the angle itself, becomes a multiple of the angle, but not in a very simple way. So it's an extensive lecture to cover the whole thing. We are going to look at some particular examples, and more advanced examples are going to be delegated to your calculus classes or physics classes to come up. So the idea is we can have trig functions applied to an angle, applied to twice that angle, applied to 3 times that angle, applied to 4 times that angle, and so on. Or we can have that trig function and square of it and cube of it and power 4 of it, and so on. Same way sine you could apply to an angle, apply it to twice that angle, apply to 3 times that angle, 4 times that angle, and so on. Or you can have that function and look at square of that function, you can look at cube of that function, and you can look at power 4 of that function, and so on. It so happens that there is a relationship between these two groups. The relationship is not all that straightforward, it's kind of rather complicated. We are going to practice some simple cases and build a little bit of a vocabulary out of the relationship between these two classes. So the idea of power reducing, what does it mean? Here power is 2, here power is 1. Okay, we are reducing from 2 to 1. It's not written here, but well, when it's not written, it means the power is 1. So power has been reduced in this formula. Opposite of is essentially opposite of double angle identities, but has a name all its own. So let's go ahead and see how does this handles itself. Well, with the example of sine to power of 4 of 4x. So what do we start with? We start with the fact that sine square of an angle is 1 minus cosine of that angle divided by 2. Okay, so this is our starting. So sine square is 1 minus cosine of double of that angle divided by 2. Okay, well, is that what I want? Well, no, I want power 4. So I go and study, well, what am I going to have, what am I going to do with power 4? Well, power 4, one way to handle it is to think of it as a square of square. Sine square, for that we have an expression, 1 minus cosine of 2a over 2. So that is what was inside the parentheses now is written this way. Just we copied this one. Now we have to square that. Now let's make sure we remember from college algebra. If you have one item minus some other item and you want to square it, what do you get? Square of the first, square of the second, and then sometimes we forget to write the so-called cross product, minus 2xy. So here when I want to square this, denominator easy, 2 squared was just 4. Numerator 1 squared is, well, 1. Second item squared, minus becomes plus cosine square of 2a. Now you have to be very careful with your handwriting. Make sure that you do not get confused. This is a power, this is a multiple of the angle. Twice the first and the second. 1 times cosine of 2a is just cosine of 2a. And in this case, we have minus twice cosine of 2a. Okay, so we have achieved power reduction. From 4, we have come down to 2. We want to see if we can push this thing even further. So I want to know if I can go all the way down to 1. Well, yes, I can, by applying the power reducing to cosine square. Cosine square, let's write it cosine. If I had cosine square of a, That would have been 1 plus cosine of 2a over 2. Well, I don't have cosine squared of a, I have 2a. So I have 2a's here, so I do a substitution. I also write 2a on the right hand side. So here let's remind ourselves, cosine square of 2a. So let me maybe write it in red here. If it was a here, this would have been 2a here. So if it is 2a on the left, it will be 4a on the right. Is that right? Instead of a, I'm writing 2a, and everywhere else I do the same thing. The net result is that I get 1 plus cosine of 4a divided by 2. So what we did here is a significant, important substitution, simple substitution. A formula written for some variable, I am looking at the double of that variable. I just double everywhere. Okay, what does that tell me? I'm going to take this and use it in this place. So I'll have sine to power of 4 of a is 1 plus cosine of 4a divided by 2 minus twice cosine of 2a, the whole thing divided by 2. Divided by 4. Sorry. Now what? Well, let's go ahead and clean the fraction. To clean the fraction, I multiply by 2. What do I get? Sine to power of 4 of a. This becomes 2, 1 cosine of 4a minus 4 cosine of 2a. Multiply by 2, multiply denominator also by 2, you get an 8. Clean it up. Now how do we clean it up? Again, it's important to be neat here. Either we start writing from the higher multiple of a and go down, or the other way around. So one way or another, perhaps I start with cosine of 4a minus 4 cosine of 2a, and then plus 3 divided by 8. So that it looks neat and clean. Or your option could be, well, start from the other one. Start from cosine of 0a, then 2a, then 4a. So either one is acceptable, but if you don't write it in a proper order, it becomes questionable. Why did this person not clean it up? So one way or another, we have a format. Let's go ahead and port this thing to the set of formulas we want to have here. Let's just write it in the style of so I have cosine to power of 2 of a. Let's divide this fraction so that it makes it look like the way the formulas are written in your software. Cosine of 2a. Let's make another set here. Sine square of a is 1/2 minus 1/2 cosine of 2a. What is it that we just discovered? Sine to power of 4. We have something for sine to power of 4 of a. To write it in the same style, let's take this thing and divide it term by term. So 3/8 minus, now you can write it 4 over 8, or you can simplify it as 1/2. It doesn't matter that much either way. So 1/2 final We have cosine of 4a, well, 1/8 of. Okay, so we are making a table, and you can make a table alongside with me. So you notice I have a power here, power 2. I have a multiple here, a power 4, multiple 2, multiple 4. So you can imagine that for sine to power of 6 of a, you can continue this process. You would suspect there will be double a, 4a, and 6a on the right hand side. You might be wondering about sine cube and so on. Well, slightly different kind of formulas apply there. Not everything fits in the same pattern. We have for even powers, we have one set of formulas, odd powers, there are multiple options. Let's go one at a time. Okay. So this is a power reducing, power 4. On the right hand side, we only see power 1. At what cost? At the cost that the multiples are going up and the expression is foaming up and becoming lengthy. So what is it that is asking here? It's asking sine to power of 4x. This 4x, that's a minor issue instead of your, sine to power of, so if I have, let me write here, if I have sine to power 4 of anything other than a, well, I replace the same thing on the right hand side. So in our problem, we have 4x. All I have to do is, let's make it clear. So instead of this 4x, it's going to replace a. So 2a is going to be 8x, and 4a is going to be 16x. So that is rather trivial. So I have 3/8 minus 4/8, which we said is 1/2, cosine of, instead of 2a, a is 4x, so it becomes 8x, and then we have 1/8 of cosine of 4a. A is 4x, so this becomes 16x, 4 of that. So 3/8, so this becomes 3/8 minus 1/2 of cosine of, what did we have here? We had 8x, is that right? 8x. And then we had 1/8 of cosine of 16x. This doesn't fit because it's plus here. This doesn't fit because it's missing one of the terms. So these don't work in our case. So that is the trend is in this section. All of the problems here have this thing built into it. Now some little bit of twists and turns here and there. Let's see what else we have. So here I have sine square, cosine square. Sine square, cosine square. So what if I have sine square of a, cosine square of a? There are multiple ways of approaching this. It's very common to trick questions that there are multiple ways because very long list of identities. So you can use double angle here, or you can go straight for the identities we had above. You notice that at the beginning I put this 3x issue aside. That's not so significant. We are going to bring it at the end. So let's go build it for general A and then come back. So sine square and cosine square, we have formulas for it. Sine square, cosine square are these two. So if I multiply them, what do I get? 1 plus cosine times 1 minus cosine over 2 times 2. So let's go ahead and write that. So sine squared was 1 minus cosine of 2a divided by 2 times 1 plus cosine of 2a divided by 2. Now again, basic algebra identities. If you have a minus b times a plus b, what does that remind you of? A squared minus b squared, is that right? The magical cancellation of cross terms. That's what you get here. So here, 2 times 2 in the denominator is 4. You have subtraction times the sum. So square of the first, or square of 1 is just 1. And then you have square of second term. Okay, what now? Next step is to say that cosine square, so we have the identity that cosine square of a is 1 plus cosine of 2a divided by 2. So that's what I'm going to use here. Cosine square of, now if I have 2a here, then I'll have 4a there. So I'll write 1 plus cosine of 4a over 2, the whole thing over 4. And then, well, just as last time, we go multiply by 2. 2 times 1 is a 2. So let's write 2 minus whole thing. Minus, I put a parenthesis so that I wouldn't make a mistake of ignoring the second term. So I multiply by 2, clean up, so it's 1 minus cosine of 4a divided by 8, and the software wants it like this: 1/8 minus 1/8 of cosine of 4a. So this is sine square of a cosine square of a. I don't have a, I have 3x. So 3x, so if I have sine square of 3x cosine square of 3x, on the right hand side, instead of a, I also write 3x. So it becomes 1/8 minus 1/8. Instead of a, I write 3x. It becomes 12x. So 1/8 minus 1/8 and then 12x, it matches this one. So 1/8 minus 1/8 of 12x. The others don't, the other won't care. So one thing we have here is this identity: sine square cosine square is 1/8. So where do we write that? I guess I write it separate category here: sine square of a cosine square of a turned out to be 1/8 minus 1/8 of cosine of 4a. Right. Next, okay, this one is a play on cosine. Okay, well, I want to encourage you to stop the video, finish this thing up, and come back and cross-check with what you have, with what I produce here, and that way it will be best. So we have okay, so I hope you learned to go and do it yourself and come back here. So what do we start with? I have cosine here, so I need to start with cosine square of a, which is 1 plus cosine of 2a over 2. That's our starting point. Well, I need power 4. So again, we set aside this red herring that I have 4x there. Just clutters our picture. And becomes additional red herring there. We just put it aside. Just go cosine to power 4 of a. So this is square of that one. Square of that one, which is square of 1 plus cosine of 2a over 2 squared. Well, we again from basic algebra remember that when we square, you're not going to forget twice the first and the second. So I go ahead and do that. Denominator 2 squared is 4, easy. 1 plus cosine square of 2a plus 2 cosine of 2a. Okay, now round 2, cosine square of 2a. If I have 2a here, then I'll have 4a there. So that is the important thing here. So 1 plus cosine of 4a over 2 plus 2 cosine of a over 4. Now we multiply by 2 in numerator and denominator, so 2 times 4 becomes 8. 2 times 1 plus 1 becomes 3. Let's write this one next. 2 times 2 is a 4. I made a mistake. This is 2a cosine of so 2 times 2 is 4, cosine of 2a. This is cosine of 4a. Your software wants it cut into pieces. 3/8. 4/8 is same as 1/2. 1/2 cosine of 2a plus 1/8 cosine of 4a. So that is cosine 4 of a. What does this problem ask for is, what if instead of a I have 4x cosine to power of 4 of 4x, or any multiple of x? Well, just substitute. Instead of a, put 4x, so 1 3/8 1/2 cosine of, instead of a I put 4x, so I make 8x, and 1/8 of cosine of 4 times 4 makes 16x, and so on. So this is the major part here, and this is the application in this problem. So it's this this form, because we don't have negative, we have positive. So I have 3/8 1/2 cosine of 8x, and then what's 1/8 of cosine of 16x. So you just put those ingredients in. Again, important thing is for you go through this process, repeat it to yourself multiple times so that you can do it under 2 minutes. Okay, so don't try to get rid of a homework. It's not a nuisance to get rid of. It's something to become friendly with. Repeat it over and over again until it happens in 1 or 2 minutes. You need to have that speed to be able to go over the calculus mountain. So this is a hill of pre-calculus. Next comes the mountain of calculus itself. So every prerequisite has to be mastered for the next level to be absorbed nicely. Let's go ahead and put this thing on our list here. So all the way up. Sorry, this thing just rolls by itself. Cosine power 4 of a, so it became 3/8 plus 1/2 cosine of 2a plus 1/8 cosine of 4a. Okay, so I'm kind of sometimes using the notation in your software. if you want to be very precise, this is not a good way to write, but you don't want to get used to that notation. The argument of a function has to be always in the parentheses, but your textbook goes for clutter reduction, so power reduction or clutter reduction, and you don't see the parentheses. However, you're better off putting parentheses everywhere and to avoid possible mistake. Okay, what else do we have? Tangent square cosine to power of 4. It's just an exercise. Let's see. Let's remind ourselves what was tangent. Tangent of a, one expression for tangent, there are many of them, was ratio of sine to cosine. Is that right? So to get ourselves started, we might say if I have tangent square of a times cosine to power of 4 of in a, I can write, instead of tangent, I can write sine square of a over cosine square of a, and then cosine to power of 4 of a. Now, out of 4, you take 2 out, so this becomes sine square of a cosine square of a, which is a problem we just did a few minutes ago, and we already have a ready-made approach to this, 1 minus 1/8 minus 1/8 cosine of 4a. So we can just use that quickly. So what was it? 1/8 minus 1/8 of cosine of 4a. Is that right? So again, this is 1/8 minus 1/8 of cosine of 4a. In our problem, a is 5x, so tangent square of 5x cosine to power of 4 of 5x is going to be 1/8 minus 1/8 of cosine of a is 5x, so it's become 20x. So it falls into this category, and so the problem is done. So let's just write this one as well. Tangent square you can imagine another formulation for this thing will be cotangent square of a times sine to power of 4 of a. That will be the same thing. So these are 3 different ways of writing the same thing, and same identity applies to them. Again, let's go back to see what was the story. Power reducing. Power reducing means from a high power you go to lower power, preferably to power 1. So there is a relationship between stuff on the right and stuff on the left. You can reduce the power in exchange for increasing the multiple. There are many options, and the formulas gradually get more and more out of hand. So you see, you get rid of the power, but at the cost of producing multiple terms on the right hand side. These coefficients get to become more and more complicated as you go to higher power. So I invite those of you who are interested in more advanced mathematics, try to go figure out sine to power of 6 and sine to power of 8 and so on, and you see that this expression on the right hand side expands. You get a triangle there. Try to discover what are the coefficients of that triangle. Okay, so became lengthier than usual, but we are getting ready for calculus. Okay, until next time, good luck and God bless.